Hello friends, welcome to PharmaChem Insight. In today's video, we will see the Woodward Fischer rule part 2, that is how to calculate the lambda max or absorption maxima for alpha beta unsaturated carbonyl compounds. So let's get started. So here is the basic structure for alpha beta unsaturated carbonyl compound. We have carbonyl group and unsaturation at conjugated position. So the carbon which is next to carbonyl group is named as alpha and the next one is beta. And X is the substituent next to the carbonyl group. So let us see the base value for these compounds. When X is hydrogen, then the compound is aldehyde and the base value for alpha beta unsaturated acyclic aldehyde is 210 nanometer. When X is alkyl group, then it is alpha beta unsaturated acyclic ketone and the base value is 215 nanometer. For acid or ester compounds, the base value is 195 nanometer. And when it is in the ring structure, for 6-membered ketone, it is 215, whereas for the 5-membered ring ketones, the base value is 202 nanometer. Let us see if there are any additional Let's understand the increments in the alpha beta unsaturated carbonyl base values. Here are the incremental values. For double bond extending conjugation, we have 30 nanometer. For exocyclic double bond, we have increment of 5 nanometer, whereas for homoanilidine, we have increment of 39 nanometer. If there are any substituents present, then the increment depend on what is the nature of that substituent and what is the position. So here are certain values. You have to remember these values. Also, generally the sample solution is prepared in ethanol as a solvent, but if there are any other solvents, then we have solvent correction values. So let us see now with the examples how to calculate the lambda max for these compounds. Example 1. Here we have kept base values and the incremental values for the substituent ready on the right hand side of our slide. So let's start with the first example. Here we are, for our convenience, we are naming the carbon compounds which are next to the carbonyl. And we have structure alpha beta unsaturated carbonyl ketone and the base value for that is 215 nanometer. Let us go to identify the increments. So we have any double bond extended conjugation? No. Any exocyclic? It is not a cyclic compound, so no exocyclic double bond, no homoanilidine. If there are any alkyl substituent, yes, there are 2 alkyl substituents at beta position, and hence we have 2 into 12 nanometer, that is 24 nanometer. By calculating, we get the lambda max as 239 nanometer. Let us go to see the second example 2. Okay, we have a 6-membered ring ketone alpha beta unsaturated compound. Let us name the carbons first. We will also name the rings for better understanding. So we have here alpha beta unsaturated ketone 6-membered ring. So the base value is 215 nanometer. Let us see the increments now. Double bond extended conjugation we have, and hence the increment is 30 nanometer. We have 2 exocyclic double bonds. The double bond present between alpha and beta carbon is exort to the ring B, whereas the double bond between the gamma and delta carbon is exoposition to ring A. So 2 into 5, we have increment of 10 nanometer. The 2 double bond which are present are heteroannular and not homoannular, so no increment. Let us see the ring residues. Here the value of ring residue depend on its position. So the first ring residue which is next to beta will have a value of 12 nanometer. Then the next is gamma. It will have a value of 18 nanometer. And the ring residue which is next to the delta carbon will have an increment of 18 nanometer. So total we have 48 nanometer. By calculating or adding all these values, we have the lambda max or absorption maxima for this compound as 303 nanometer. Okay, let's move to example 3. Let's name the carbons first, which are next to carbonyl group. Then we'll name the rings as well for better understanding. So let us identify the base value. We have 6-membered cyclic ketones, so base value is 215 nanometer. We have extended double bond conjugation, and hence the increment is 30 nanometer. We do not have an exocyclic double bond. Please note that the carbonyl compound we are not considering as exo. We need the alkene group via double bond to be exo to the ring, and hence no increment due to exocyclic double bond. Okay, this group, this is a homoannular diene as the two alkene groups or two double bonds are present in ring B. So it is homoannular diene and we have increment. Then for ring residue, we need to consider their position. We have one increment at or the ring residue which is next to alpha carbon. So there is addition of 10 nanometer. Then we have another increment or another ring residue at beta position and the next one at delta position. So according to that, we are adding the increments and we have an addition of 40 nanometer. By calculating, we get the lambda max or absorption maxima of 3 to 4 nanometer. Let's move. Example 4. So here, let's name the carbons first. We have, okay, alpha beta unsaturated carbonyl compound, hence the base value is 195 nanometer. Let us see the increments. No double bond extending conjugation, no exocyclic double bond, no homoannular diene. We have only ring residue. There are two ring residues, one at alpha position, one at beta position. So we have increment of 10 plus 12 nanometer, that is 22 nanometer. So we have lambda max, that is absorption maxima of 217 nanometer. So here we are ending these examples. If you want me to solve many more examples for these kind of things, please put your comments in the comment box. Thank you.